Okay, let's dive right into an explainer of one of the absolute most awe-inspiring feats of engineering on the planet. We are talking about machines that don't just shape the Earth, they literally devour it.
So I want you to imagine a machine so unfathomably huge that it completely breaks our understanding of what a vehicle can even be. I mean, if you picture the absolute biggest dump truck or crane you've ever seen in your life, you need to multiply that scale dramatically.
Because we are talking about 14,200 tons of raw earth-moving power. It's one of those numbers that's honestly kind of hard to wrap your head around. It represents this massive structure of steel, gears, and electrical cables that pushes the absolute boundaries of industrial design.
Which brings us to Section 1, Meet the Giants. Let's officially introduce the record-holding titans of the mining world, the legendary siblings of the bucket wheel excavator family, the Bagger 288 and the Bagger 293. To truly understand how incredibly massive these titans are, just picture this. At 96 meters tall, you are looking at a machine the exact same height as the Statue of Liberty. And as for that 14,200-ton weight, that's the equivalent of stacking up 8,600 passenger cars. It actually holds the Guinness World Record for the heaviest terrestrial vehicle ever built.
But the really crucial point here is its daily output, right? It doesn't just sit there looking big. Every single day, it swallows 240,000 cubic meters of earth. To put that into perspective, imagine a regulation-sized soccer field and then dig straight down for 30 meters. That is how much material it moves daily. It's equal to 10,000 standard dump truck loads, which is just insane.
So how does something this massive actually function without just tearing itself apart under its own weight? Let's dive into Section 2, Anatomy of a Behemoth.
The secret to its continuous digging power is right here on the business end. It's this massive bucket wheel measuring 21.6 meters across, which is basically as tall as a 4-story building. It features 18 integrated buckets, and as that giant wheel revolves, each individual bucket scoops up over 15 cubic meters of rock and soil, transferring it all seamlessly to a conveyor belt.
And to really grasp the scale of that cutting wheel and the massive 70-meter boom it sits on, just take a look at how it completely dwarfs the normal-sized passenger cars driving past it. I mean, it literally looks like a spaceship that just landed in the middle of a rural landscape. When we compare the two most famous siblings of this mega machine class, the Bagger 288 was built back in 1978 by Krupp, while the slightly heavier 293 was completed in 1995 by Tack-Raff. Both of these giants cost roughly $100 million and took a full decade to design and assemble. While they do share records, the 293 actually boasts an upgraded bucket volume for even more efficient extraction.
Now, you'd probably expect an absolute army of people to run this thing, right? Well, despite containing over 120 kilometers of cabling and featuring 23 onboard service cranes just to lift replacement parts, the whole operation is managed by a surprisingly tiny crew of just 5 people. The main operator actually sits in a specialized cab that moves up and down exactly like an elevator just to maintain a clear view as the entire machine rotates on a huge 20-meter slewing ring.
And this brings us to what I think is an absolute engineering miracle. How does something weighing over 13,000 tons not just sink straight to the center of the Earth? Well, by distributing its immense weight across 12 massive crawler tracks, each nearly 4 meters wide, its ground pressure is restricted to a mere 1.71 bar, meaning, believe it or not, it leaves tracks no deeper than your own footprint on soft soil.
You might be wondering what actually moves a footprint that heavy. Let's explore Section 3, Powering the Beast. And spoiler alert here, you are not going to find a standard gas tank on this giant. Because 16.56 megawatts, that is the external electrical power this machine demands just to operate. A traditional diesel engine simply couldn't scale to this level of continuous, relentless digging. So instead, it is tethered directly to the local power grid, fed through incredibly thick trailing cables carrying 30,000 volts of electricity.
Section 4, The Impossible Journey. This brings us to a really legendary moment in industrial history. Back in 2001, the Bagger 288 had finally finished its work at the Hambach mine. The coal seams were exposed, and the machine was desperately needed at the Garzweiler mine, which was 22 kilometers away.
This created a logistical puzzle of epic proportions. The transport engineers faced a monumental choice. Option A, spend 15 million marks and 6 entire months taking it apart piece by piece. Or Option B, attempt a 10 million mark maneuver to just walk the 13,500-ton Leviathan fully intact right across rural Germany.
As you probably guessed, they chose to walk it. It was a highly tense operation that required 14 months of prep just to survey every single buried gas line, culvert, and drainage tile along the entire route. The 3-week journey even involved crossing an active autobahn in the dead of night, leaving track marks in the asphalt that, amazingly, were easily patched the very next day. But honestly, crossing the autobahn was the easy part compared to crossing a live river. This was an absolute edge-of-your-seat puzzle. Engineers laid large steel pipes so the river water could keep flowing, piled tons of rocks and gravel on top to create a temporary roadway, and calculated that the machine's incredibly low ground pressure could safely roll right over it.
10 meters per minute. That was its absolute maximum speed during this 3-week trek, just crawling along day and night. At that speed, the machine's sheer momentum makes it incredibly difficult to stop if something starts to go wrong.
The human tension here was just unimaginable. The chief transport engineer reportedly checked his math 11 times and barely slept, functioning on like 4 hours a night. He knew that if the ground under those crawlers collapsed by even 20 centimeters, the massive shift in weight would send a massive shockwave straight up the structure, potentially destroying the entire 70-meter boom.
Well, thankfully, the riverbed held, and the Autobahn survived, which brings us to Section 5, the future of megamining. The walk was a complete success, and the bagger's legacy as the undisputed king of surface mining was firmly cemented.
Even today, these machines continue to be the ultimate backbone of open-cast mining systems. They operate with relentless electrical efficiency, doing the continuous earth-moving work of up to 40,000 manual laborers. However, changing environmental policies mean they do have an expiration date. They are slated to operate only until the German coal phase-out, which is currently scheduled for 2029.
Which leaves us with one fascinating unanswered question to wrap up this explainer. When 2029 arrives and the mines finally close for good, what actually happens to these colossal titans of engineering? Do we spend millions to dismantle history's heaviest land vehicles, or do they just remain standing out there in the German countryside as towering monuments to human ambition? It is definitely something to think about. Thanks so much for joining me, and keep your curiosity digging deep.